Okay, so I'm helping you watch the last one because it's important for this. We need Pythagorean theorem to do these special right triangles. So there's two types of special right triangles. One type is called the 45, 45, 90 right triangle. And it's literally because it's two 45 degrees and the right angle. So here's how we make it. I'm going to take a square. Okay, and we know from our in-class work that squares are 90 degrees on all sides. Okay, and we know that these are all the same length, right? So if, let's just say, if this was 2, it would be 2 all the way around, right? It's the same length all the way around. Now, I'm going to take the square and I'm going to cut it in half. So I'm going to ignore the bottom half for just a second. I'm actually going to cross this out. This is why you watch the videos. Okay, so this here means that this has been cut in half and this has been cut in half because the diagonals of a square bisect the angles. It's just, that's just, so these are 45. That's why it's called, what color am I going to use today? I don't know. Orange, sure. That's why it's called a 45, 45, 90 triangle. Okay, now bear with me here. We're going to find the longest side. That's what we're going to do. I'm going to find the hypotenuse. So I want to find out what C is. So this is A, B, and C. Okay, so yeah, Pythagorean theorem again. So A squared, that's why you needed last time, plus B squared equals C squared. Well, A squared is 2, B squared is 2, C squared we don't know. So we're going to call it, we're just going to leave it as C squared. A squared, B squared. Okay, you're still with me, I'm hoping. If not, just leave. I'm just kidding. If not, restart. Okay, so this is 4. So this is 4 plus 4 equals C squared. This is 2 4s. So this is 8. All right, so C was going to equal the square root of 8, which I know is some numbers, but this is going to be 2 times the square root of 2. Okay, now this 2 right here was a really dumb idea because I should have done 3 or 4 or something. But if you do this with any square length, this number and this number and this number will always be the same. So here's what we usually say is that if I have any 45, 45, 90 triangle, which is represented this way usually because it's the same on both sides here, then if this side is S and this side is S, then this side will be S root 2. So this is one of, hi Koshka, please leave. This is one of the 2 special right triangles. One of 2 special right triangles, okay, is made of half of a square. Stop. I'll be right back. I didn't eat the cat, I just gave it to my boyfriend. Okay. So that's the first type of special right triangle is 45, 45, 90 triangles. They have this specific property where it's 7, 7, 7 root 2, 11, 11, 11 root 2, 27, 27, 27 root 2. Okay, so if it's a 45, 45, 90, you already know what that is. Next, I had to find a different color, is the 30, 60, 90 triangle. All right, so the last one was made from cutting a square in half. This one's made from cutting an equilateral triangle in half. Okay, so here's my beautiful equilateral triangle. All right, great. We know this is equilateral when all of the all the angles are the same and all of the sides are the same, right? So that's equilateral. So I'm just going to use 7 because why not? Let's say all these are 7. Okay, now I'm going to cut this in half. So I don't care about, oh, that was a really bad choice. Let's do 8s. Sorry, I just thought about it again. So I'm just going to cut this side off. So what that means is that the bottom has been cut in half, which means this is actually 4 long right here. This is 30 degrees, and this one's 90 degrees. So this is my 90, 30, 60. I never say it in that order. This is my 30, 60, 90 triangle, right? Because it's been cut in half. Okay. In this triangle, let's find this side length. I don't know it. Okay, well, 8 is C, because it's my longest side. So let's just say this is A, and this side, this height right here is B. I don't know B yet. Okay, so I'm going to do A squared plus B squared equals C squared, which means 4 and 8. I don't know why I wrote that again because I already wrote it above, but it's fine. I wanted to keep it the same. Okay, so let's go. 4 squared is 16, and then 8 squared is 64. So if I subtract 16 from 64, I get that B squared equals a number. Hold on. Is that 48? That might be 48. 64 minus 16. 48. Okay, great. And then I can square root this, right? So B equals the square root of 48, which is should be 4 root 3. Which I knew, not because I knew what the square root of 48 was. What did I just say? 4 root 3. But because I knew the trick of these triangles. Okay, so this 4 is the same as that 4, right? These are, if this was a 7, this would be a 7. If this was 30,000, this would be 3,000 root 3. Okay, so those two are the same. And then this one's always twice as big as the longest side. Sorry, the longest side is twice as big as the smallest side. Because of how I made it with the equilateral triangle, it's always half to make the smallest side. So no matter what I do, when I see a 30, 60, 90 triangle, it always has this property. So let me write that out on the side. Okay, so my second type of special right triangle, 30, 60, 90, is whatever this side is. This is 2 times that side, and this is that side root 3. Always. So let's use it. All right, we're going to do like 2 or 3 of these. So this one is a 45, 45, 90, and I know that because it's isosceles, right? So if it's isosceles, that means that these two are the same, which means that both of these have to be the same. Okay, so we know from matching it with our top one that whatever this is, the first number is the same as the 2 side numbers. So x, I just take this 5 right here, and I know that x equals 5. Done. No Pythagorean theorem needed. It is okay if you want to use it, but it's not needed, which I think is pretty cool. Okay, here's another 45, 45, 90 triangle. And I don't know that just by looking at it right away, but I know that this has to add up to 180. So 90 plus 45 is 45 away from 180. So that tells me that these two are the same, 45, 45, 90. So I take this side number, and so x will be 8 root 2. So I take that number. All right, that's the number that matters. The root 2 is just for the longest side. Okay, let's do one maybe the other way. All right, so this is a 30, 60, 90 because it has to add up to 180. And there's already 90 and 30, so there's 60 left, right? So this is 30, 60, 90. Basically, if I see any of the 2 numbers, the third one's already there because there's no other way to make these triangles. So I need to find the longest side. Now I know that the longest side is twice as big as the shortest side, which means I need to find the shortest side. Okay, so this middle side is 9 root 3, which means that this side is 9, which means that this side is twice that. So I know that x equals 18. All right, now I'm going to be super honest with you. You could just do Pythagorean theorem for all of these. You would need to note that this side is also 8 because this only gave you 2 of the informations, and that this side's twice as big as this one, so you have to do a little bit more math. But if I only give you a little bit of information, you can totally do this. Why am I teaching you this then? Because we're going to start doing things for trigonometry very soon, and these numbers, root 2 and root 3, are going to show up a lot. So if you understand where all these numbers came from up here, then you'll be able to do the other stuff a lot easier because you'll recognize the root 2s and the root 3s as we do trigonometry. So give it a shot. If you're still confused, it's okay. Don't stress about it. This is one of the topics that people keep asking me about all the time, and so I know it's hard. I just wanted you to recognize that these 3 numbers are all the same, but this one has a root 2 on it. And these 2 numbers were the same, this one with a root 3, and that one double the smallest side. It just happens that way. So, hope that helped. Email me if you didn't, and I'll see you in class. Okay, bye.